Hello students, welcome back to our new video. It is about Euclid's division principle. So here the principle is used by another word called lemma. Lemma is the word we are using to represent a statement, so which is already a proven statement, to represent about a already proven statement that is uses to prove some other statements. So already proven statements is going to use to prove some other statements. So in that the main lemma we usually observe in the textbook class 10th is Euclid's division lemma. So Euclid division lemma is nothing but we are using a division principle. So we are using a division principle which is already proven statement. So division principle is already proven statement. So that principle we are using, division principle is using to prove something other statement. So here we are going to use the division principle to find out some other principle. So we will see what we are going to find out by using Euclid's division lemma. So before that we will see what is the division lemma. Here the Euclid division lemma states that for any two positive integers, we are assuming that two positive integers here, one is integer is a and other one is a b. Here there exist integers q and r. There exist unique integers q and r such that a is equals to bq plus r. Here students, a is here dividend. So already we have a principle, division principle. What is it? Dividend is equals to, we know that the principle dividend is equals to divisor into quotient plus remainder. So this principle already we know that. So that principle we are using here, and we are applying this principle to find out the relation between two positive integers a and b here. So that relation is here, a is considering as a larger number and it is nothing but dividend, okay, and b is a smaller positive integer from the a and b. A is assumed as the larger integer from the a and b, and b is assumed as a smaller integer from a and b, where we are applying the division principle in between a and b, so that a is a dividend, b is a divisor here, and a is equal to bq plus r. So dividend is equals to, b is here divisor, then what is q here? Q is a quotient and r is the remainder. So in this principle, a is equals to bq plus r. So we must write the condition for the range of the remainder value. What is the range of the remainder value here? Range of the remainder is nothing but more than or equal to 0 and as well as less than b. B is here divisor. For example, divisor is 3. If b is 3, then what will be the remainder range? So 0 is less than or equals to r is less than b, that is b is here 3. So r value definitely either 0 or 1 or 2. So these are the possible values of the remainder when we divide any positive integer by 3 here. Okay. So let us apply this division algorithm, division principle, to find out HCF of any two positive integers that we are having. So let us see how we can find out the HCF of two positive integers by using Euclid division principle. So Euclid division algorithm or principle we are applying to find out a HCF of any two positive integers. So by taking an example, we will discuss this division algorithm to find out HCF of two numbers. So it is very important question, students. We will definitely observe any one question for very short answer questions. So division algorithm uses to find out HCF of any two positive integers, students. So let us see. Yeah, so we are observing here an example problem. Find HCF for the following by Euclid's division algorithm. Euclid's division algorithm is nothing but the division principle using in the step-by-step procedure to find out HCF of given first pair of numbers here is 72 and 108. So let us take here the first example. Okay, so let the given numbers here, what are the given numbers here? 72 and 108. So here already before I explain about division algorithm, I said clearly that larger number will be assumed as a. So a is equals to 108 and the smaller number is considered as the divisor, that is b is equals to 72. So we know that Euclid's division algorithm, we have to write that statement definitely here. We know that Euclid's division algorithm, Euclid's division rule is, what is the division rule? You know already that Euclid's division rule. Before that I explained the in video. Euclid's division algorithm or lemma, that is nothing but a is equals to bq plus r and 0 is less than or equals to r is less than b here. So a value is here nothing but 108, okay, and 72 into q plus remainder r. So let us see 72 how many time divides here 108 72 one time it divides. So what is the remainder here? 72. 1 from 108 we will subtract 72, that is 8 minus 2 is a 6, 10 minus 7 is 3. So the remainder value is here 36. Remainder is a 36. So here we can observe that remainder 36 and divisor 72 and 108 is a dividend. So here the remainder should be 0. So the procedure must be followed up to remainder value becomes 0. So for that purpose, the division algorithm once again we will apply here for the second time. So here for the second time the divisor becomes a dividend in the next step. So divisor becomes dividend in the next step and the remainder becomes a divisor, that is 36. How many times? 36 2 times 72. Then what is the remainder? Remainder is nothing but 0. So the procedure, this division procedure must be followed as many as the steps we required until we makes nothing but until we get the remainder value is equals to 0. Okay, so here in this procedure we can observe that 72 and for 72 and 108 we got the remainder 0. At which divisor we are getting remainder 0? At the divisor 36. So the divisor itself is considered as a HCF value. So therefore HCF of 108 and 108 and 72 is how much here? 36. So divisor itself is the here HCF. So divisor whichever gives you the remainder value is 0 for unique number q, that is nothing but 2 here is nothing but 36. So same procedure we will follow for any two positive integers that we are going to apply the Euclid's division algorithm or procedure, okay, for any two positive integers. So let us see second example also here. What is the second example? The numbers here they did not give directly. So first what they gave, smallest multiple of 30. So what is the smallest multiple of 30 here? So given values we are assuming by a and b. So a and b, so let we are assuming that the given number a and b. So 30 multiple of 30 is nothing but smallest multiple of 30. What is it? Smallest multiple of 30 is what is it? First multiple itself only, no, that is 30 only. And another number is that largest two digit even composite. We know that composite is nothing but a number which has the factors more than 1 and the number itself, that is nothing but the numbers which are other than prime numbers. Other than prime numbers all are the number other than prime numbers is called as composite number. So we already know that composite definition, and here the given value is here largest two digit even composite number. So even composite means nothing but largest two digit number is 99. Okay, 99 is gives you the other quotient values. When you divide it by 3 here we are getting 3 as also factor of 99, so it is a composite number, and but it is largest odd number it is. So here in the question they gave even integer, so that is why the even largest two digit number we will consider as here 98. Okay, a is how much here? A is a larger number we consider, as I already explained in the previous problem. Larger number will be a and smaller will be 30, that is b. So we are applying the division algorithm, that is a is equals to bq plus r, and 0 is less than or equals to r is less than b here. So dividend is how much? A is 98 and divisor is 30. 30 is how many times it will be divides, and it makes the value what remainder will be. Okay, then the range of remainder is nothing but here from 0 and less than 30. And next here 30 how many times? 3 times. 33 times 90. What is the remainder here? 8 is the remainder. So remainder we did not get a 0. So as the division statements will be applies until we will get remainder value 0. So for the next time the dividend becomes the previous divisor. So the previous divisor 30 will be considered as dividend, previous remainder will be as a divisor. So how many times 8 divides 30, and what remainder it gives here? 8 divides 3 times. So 3 times 24 it gives, and remainder is how much? 6. Okay, so then the remainder value is between 0 is less than or equals to r is less than, here divisor is 8, so it is 8. Okay, next the same statement we will apply for the next value. So let us apply it for next value. So for the next time divisor becomes dividend 8 and remainder becomes divisor, and how many times plus remainder value. So how many times? Only one time. What is the remainder? 2. And the 0 is less than or equals to r is less than, here divisor is 6. Okay, next step 6 is equals to divisor is here now 2. 2 how many times? 3 times, and now remainder is 0. So what is the HCF here? Therefore the HCF is the divisor. What is the divisor here? 2. So the HCF of the given numbers, that is nothing but the first multiple of, that means smallest multiple of 30, and the largest 2 digit even composite number is nothing but how much we got? 2. I hope you understand how we can find out a HCF of given two positive integers. I hope you understand how we can find out HCF of given two numbers by using Euclid's division algorithm. So here I have shown you two examples. I hope you will solve more and more problems to get perfect in this concept. So it's very important topic, students. Definitely we can expect a question for very short answer questions in public examination or in board examinations. So I hope you practice more and more problems related to finding HCF by using a Euclid's division algorithm. Okay students, if you understand this concept, I hope you will share this video to your friends and beloved ones. So let us learn it together.